All right, let's talk a little bit more about these electrons. I had said that electrons carry energy, and they are electrochemically attracted to the protons, right? And so as a result of that, they have energy, so they're moving, and depending on how much energy they have, they're closer or further away from the nucleus. And so the analogy that I always use is of a child with its mama. And children have energy, right? And mama, they're attracted to mama when they are in a slightly potentially threatening environment. So if I was in class, I would be saying, standing up in the front of the room, maybe if I had a mother and a child of a certain age, somewhere between 2 and 3, sometimes they're a little bit leery of strangers. And so if she had come into the room and was standing in the front of the room, the child, because it's a child and is walking around, a toddler, it would be walking around, but it'd be a little bit leery of you guys. And so it would be attracted to mom because mom represents security, right? So it would be orbiting mama. And but it would only go just so far because it's a child and it has energy and it's going to move, how they do. So it would stay relatively close. That's my point. And then we can look at another scenario. We say we have another mama with a different child that happens to be hyperactive, has more energy. And so that mama and child, the child would also be leery of people, didn't know, but it would have more energy. So just the fact that it had more energy would mean that it would stray further away from security from its mother. And so this is the same thing that we have with electrons. If you have low energy, electrons can carry different amounts of energy. If you have low energy, you're going to be in a lower energy orbit. You're still flying around the nucleus, but you're closer than if you have more energy. So when we talk about electron orbits, what we find is that they carry different amounts of energy, and so they orbit closer or further away from the nucleus. And in most cases, you're going to be able to have 8 electrons in each of those orbits. All of them, except for that one that is closest to the nucleus. And that one, it only holds 2. Now, if you go into chemistry and you talk about some of these atoms we don't talk about that have large numbers of protons, this rule won't apply. There are some atoms that have even more than 8 electrons in their orbit. Now, a point that I need to make, and I don't think I've made it yet, is that every atom starts out with the same number of electrons as protons. So depending on how many protons you have that many electrons. And let's see in your notes here, we have sodium. And so if you look, and sodium is designated Na. So chemistry is based on Latin. So that's the abbreviation for sodium in Latin. So it's Na is sodium. And so if you look at that diagram of that atom with Na, you see that you have 2 little circles that are 2 electrons that are orbiting close to that nucleus. And then you have electrons that are in 2 other orbits progressively further away. And those orbits are filled with 8 electrons. And so if you look carefully, you see that outer orbit of sodium has 1. Now, so what, right? You're thinking right now, I don't care. Well, the atom does. The atom does. Atoms have desires. No. They gain stability. And so stability is something that atoms interacting with each other will work towards having this stability. Now, just as a point, so when you look at these diagrams, it looks like those electrons are really close to the nucleus. Not at all. There is a huge amount of empty space in an atom. So just as an analogy, if I talk about the nucleus being the size of a golf ball, the closest electrons, the ones with the lowest energy, would be 1,000 meters away. So there's huge amounts of empty space. So what does this mean? That means when atoms come together, the nucleus is way the heck off. It's the electrons that interact with each other. So that brings us back to this a desire thing. They desire to have filled outer electron shells. But if you are that sodium that's in our notes there, and then you have one in that outer shell, how can you do that? And electrons, you can give them away, but you have to give them to somebody. They don't just go off on their own. They go to another atom. So interestingly, or maybe not interestingly, but look right next to sodium and you'll see Cl, chlorine. Now chlorine, if you look carefully at the outer electron shell, you say, why, it has 7. So what do you think might happen? We had said chlorine needs 1, sodium needs to get rid of 1, and that will fulfill the rule of 8s. That's gaining stability. That is this giving. If you give away an electron to somebody else, if as a sodium, give it to chlorine, what happens is you said, yes, this is what I want. I'm stable now. And chlorine says, yes, finally, I have filled my outer shell. Now, there's one other point. If you are, we'd said you start out with equal numbers of protons and electrons, equal numbers of positives and negatives. If you give one of your negatives away to get stability, that means you have 1 extra positive. And if you are chlorine, which received the negative, and you had equal numbers of positives and negatives, that means you've got 1 extra negative. And so what we call these, so that makes these atoms charged. So if you're sodium and you gave away a negative, you have a positive charge. And if you're chlorine and you received an extra negative, the electron, you have a negative charge. And that means that positives and negatives attract. They come together, they stick together, and what do you have? Salt, sodium chloride, salt. They stick together because they are what we call ions. So the sodium becomes what we call the cation ion. That means it's positive. And the chlorine becomes the anion. That's the negative one. And positives and negatives attract and they stick together. This, I've just explained ionic bonding to you. One of these forms of bondings. We have 3 forms of bondings that we're going to talk about, and you already know one of them, ionic bonding. It's exciting. Yeah, it is. All right, I'll come back and we'll talk about covalent bonding next.